Hey everybody, thank you so much for coming out this afternoon. That's been a long conference, so really appreciate it that you're here. So first, a little bit about me. I'm Anne-Marie Fred. I work in IBM's Cloud and Smart Infrastructure Group. I've been doing cloud technology since 2011, DevOps since 2011, Chef since 2011, and I've been working in my current group since last year. So this slide just shows two of my favorite things, which are scuba diving with my husband and doing cool things with my kids. So that's my husband and I in a shark tank in an aquarium, waving to our kids on the other side of the glass. All right, so in the beginning, right, or at least in the year 2005, there were a lot of long-running servers out there, a lot of hardware going on. And long-running servers are fantastic. They're secure, reliable, well-tested, they're backed up, carefully monitored, carefully controlled. They're never going away. But companies, they're always under a lot of pressure to move and adapt quickly. So then there was cloud. So cloud is this disruptive technology. It allows us to have new models where we create and destroy servers very quickly, within minutes instead of days or weeks. And automating the infrastructure setup steps is so key with cloud because that's where you really get the velocity that allows you to make changes quickly as a company. But it takes practice to succeed with cloud, and not everybody can do it. So, for example, you find that if you make your systems distributed and fault tolerant, they're going to behave a lot better in this world than if you have something monolithic. So let's talk a little bit about cloud adoption patterns. I think my slides are out of order. That's okay. Go back one. My computer's messing with me. It's actually skipping the next slide. So I'll just talk to it. So we have three basic types of cloud that we work with. There's private cloud, which is where it's hosted in your own data center. Public cloud, where it's hosted in somebody else's data center. And hybrid cloud, which in my world is where you have applications or services that are taking advantage of services running on multiple cloud providers, whether those be private, public, or both. Most of IBM's enterprise customers actually adopt virtualization first, then private cloud, then public cloud, and eventually hybrid. But we also see customers that will go to public cloud first, then private cloud and hybrid, always public cloud. We see different patterns, but it's actually mostly private first for us. And really, you need the infrastructure automation that Chef provides, or something similar, in order to take advantage of that cloud provisioning. And with this, we're able to reduce our deployment times for applications from days to minutes. And this was really a revolutionary change for us. I mean, it changed my day job about 2 years ago to where it would take us about a week to set up the first release of our new software on a developer's workstation, and then we go from there. And by the time we did our first little continuous delivery system, it was taking about 5 or 6 minutes. So here are a few of the motivators for why you would want to actually try to do private cloud. Maybe you want to mix your stable, secure internal services with servers, services that are available on the internet, like social, for example. You might want to do bursting, where you do rapid scale up and scale down, so your base services are in your own data center, but your extra load is handled by the cloud. Or you just might want to let a cloud provider manage some of your infrastructure. Maybe you're a small company and you don't want to have 50 people in your own data center. But if you're going to do that, you have to consider, is the complexity of hybrid cloud really worth it? It's not for the faint of heart. And what we found works best is if you adopt hybrid cloud incrementally over time. So don't just jump into it. Start small. Figure out what's the most important thing that I need to put on hybrid cloud, and build expertise in that area. And then use Chef to maintain your sanity as you go through that. And some percentage of customers will never use cloud. And I'm actually about to get into some of the reasons why. So this is going to be our story, how the Smart Cloud Orchestrator team went through this and some of the pitfalls we ran into and what we learned. Hopefully you can learn a little bit about it yourselves. So first we start out with just plain old virtualization. So we have a bit of a chicken and egg problem in that we are building a cloud provider, so we can't just put it on the cloud to start with. So we started with VMware, vCenter, ESXi. And the first thing we wanted to be able to do is install our product. And we wanted to do it repeatably and repeatedly so that it would be reliable and easy to do. And I will tell you, getting this right for a multi-server environment like we deploy took us months. So, and we have 3 basic topologies that we install using our installer. We have an all-in-one box that we use for like salespeople who are running demos, kind of like a la DevStack, OpenStack thing. And then we have a demo-sized multi-server. So it's our more standard topology. It's 5 or 6 servers, but they only have like 100 gigabytes on each disk or something like that. And then we have our production high availability. So we need to be able to install and deploy all of those different environments constantly in order to make it repeatable and reliable. And Chef is what makes this possible because it's basically the same recipes, just with different environment and no definitions. And we did this incrementally. So we came from where we were pulling in products from different parts of IBM to make our own thing. So most of them ran with install shield or SH scripts to install themselves. And so step 1 was really just wrap an SH shell script in Chef and execute it from there. At least you get started. And then you tack the most problematic installer and you actually write a real Chef recipe. And then you go on to the next step. But we also had a really great head start. So this is a look at our Chef repository. There's a little bit of code color or color coding there. So let's see if I got this right. The orange comes from ops code. The blue was from IBM. The red came from Rackspace, and the green came from other open source. So as you can see, we only had to write about half of our cookbooks. Most of the Rackspace stuff is the OpenStack installer, so that was a big help to us. So continuous testing. The next thing we wanted to do was to be able to test every change that our developers made as they checked it in. And so we created a continuous testing pipeline. So we originally called this a continuous delivery pipeline. And then I realized we were being posers because we weren't actually delivering it like this, except internally. So it's a continuous testing pipeline. And basically what happens is a developer checks in to change the source code. They request a test build, and the Jenkins server, so actually it's the RTC, Rational Team Concert server, builds the source code. It runs all of our static code analysis checks, including things like Food Critic against it. And then if it passes all those checks, Jenkins takes over, kicks off a deployment of the 5 VMs that we need. Make sure I get this right. It installs Chef's server on the first virtual machine, and then it bootstraps the rest of the virtual machines using a combination of Chef Client and Knife. And then once the system is up and running, it runs our automated functional tests against the whole platform. And if it passes all those tests, the developers can deliver their changes. And then once a day, there's sort of a big bang build where everybody's components get run together. And that runs an additional set of tests that you can only see when everything's run together. We would love to run that on every single build, but it takes hours, so it's not worth the effort. We got to be fast for the component test. And here's just a little example of one of our integration tests. So it's basically making sure that you can actually deploy a VM on the OpenStack that you just provisioned, and if it fails, then the developer won't be able to deliver that change. I'll have to figure out what went wrong. So the next thing we had to be able to do was stand up test systems on demand for whoever needed them. So, some of our testing is still done manually. You're never going to automate everything. Also, we have people that build content on top of our cloud. So they want to have like the latest version running that they can test against. And so, again, we got a lot for free with Chef. We took all of our automation software that we already had. We created a self-service portal called Deployinator, where you can request a new test system yourself. And it stands up the 5 or 6 VMs, runs the installer, it runs Chef, it runs recipes, everything comes up. It takes, an hour, something like that. And then a couple other things that we found were very helpful in this environment. We have an auto expire on there, so if you don't do anything to flag the system to be saved, it just deletes it automatically after 4 days. That helps our resource management. And we also added a snapshot the environment feature, so it'll automatically save, do a VMware snapshot of all the VMs that it's provisioned, and you can revert the environment, so it'll all bring them back up. And our systems are configured in such a way that when they boot, if you boot them all at the same time, they kind of magically, the services come up and they talk to each other, so it works pretty well. All right, so finally, we're ready for actual private cloud as opposed to just fancy virtualization. We have a lot of internal users who don't need today's build. They need a stable GA release so that they can use it and build their own content on top of that. And it's also good for us to run a large-scale, long-running private cloud so we can do our performance tests and our long-running tests and also get experience what it is like to run our own, product in an operational state. So what we have for that is our internal platform as a service that we provide. So we have a few long-running instances of our own private cloud software, and on there you can author or test your business processes. You can create, test, or use service catalog entries. You can create and deploy virtual system patterns and virtual application patterns. So, by the way, there's Chef on that last one. So we have a feature where if you want to use Chef, you can just drag and drop a machine onto a pattern, drag and drop a Chef client installer script package onto the pattern, and then drag and drop any recipes that you want to have run. So that's nice if you're not a Chef expert. So yeah, this is great practice for us, seeing what it's like to actually keep our cloud up and running. And it speeds up the dev and test processes for everybody else who needs to build on top of us. And the best practice that we have here is that we are able to automatically insert compliance scripts into the patterns that basically run IBM Endpoint Manager and do security checks on the systems. So we can make sure that all your patches are kept up to date, that your passwords are expiring when they're supposed to, that you don't have stupid passwords, things like that. All right, so public cloud. On our own development team, we didn't really ramp up our own usage of public cloud until IBM acquired SoftLayer about a year ago. So the first way that we really decided to take advantage of it was for beta programs and demos. Public cloud is great for this because it's outside of our firewall. So we don't have to deal with all the paperwork and headaches that come with getting people a little VPN tunnel into our own data center and things like that. And we use the same Chef automation. So basically what we can do is we can set up environments for customers and hand them the keys. So we just we use the same deployinator that we had in our test environment. We made a copy of it out in SoftLayer, and now people who are administering our demos or beta program can just go in and click and say, I want a new system. I want it to be available for this many days. And it stands it up, and then we basically hand a customer the keys, say, here you go, have fun, play with it. And when we're done with it, we tear it down and we create a new one. So it's all automated. Well, okay, that would be a lot. It's mostly automated as much as we can. And it's a whole lot easier than doing this in our own data center or going out to the customer site, which is what we were doing a year ago. We were constantly deploying these at customer sites. Very expensive. So hooray, cloud! Woo! We love cloud. But we ran into some significant challenges with this. First one is different base images. So if you're running something in your own private cloud or your own virtualization environment, you pretty much have control over what your base images are. But out in the public cloud, they're going to tell you what the base images are, what version of the operating system you get. You might have 4 or 5 or however many choices, but not exactly what you want. And Chef is actually very helpful here because all we do is we put in the Chef recipes what the sort of baseline is. And if it's not in the base image on one environment, it's going to get added. So we sort of have the same starting point for deployments. Second one, so does anybody know what this graph shows? And I'll give you a hint, the title is a clue. Any guesses? Be brave. That's a server getting very, very busy all of a sudden. It's an internet worm. So, caused by one lousy password. So basically we found that our virtual machines out on the internet are attacked by internet worms several times per hour. It happens constantly. When you're used to developing inside your own cozy little private data center, you don't have to worry about this, right? Because most of the attacks have been blocked. But what happened is we had one virtual machine which had a lousy password that somebody deployed onto our ESX server. It was running out in soft layer. And people assumed it was fine to have a lousy password by default because SSH was always disabled. But then there was a problem, and the developer said, oh, I'm just going to enable SSH for a minute, fix it, and then disable it again, but that was too late. And that was on a Friday. And our first indication of a problem was that we got an email saying, you have a 16 terabyte data overage. How are you going to pay for that? So we went and looked at our monitoring data, saw that, and pretty quickly realized what the problem was. And then we had a blameless postmortem. How are we going to avoid this in the future? So it was a good learning experience. So security, yes. So now we also have anybody who wants to start using SoftLayer is required to go through some self-paced online basic security training. So that's a good thing to do. We also have tools that everybody's required to run against their products. One is called AppScan Source, which is a static code analysis tool, and one is called AppScan Web, which is a tool that runs against your actual application's web front end. And they both try to hack into your software and point out all the security vulnerabilities, and then you go through and fix them all. So that helps. Also, as you saw, monitoring, very helpful, right? And then patch management, keeping up with the patch management. So we like IBM Endpoint Manager for doing that, but Chef can help with that as well. And then cost. So when you have your hardware in your own data centers, it's pretty easy to keep a control on the cost because it's a capital expenditure. So you just determine how much you're going to spend on capital. But public cloud's costs can really sneak up on you. So we have virtual machines and software licenses, networks and subnets, firewalls, bandwidth and usage charges. So what we've learned from this, basically, we have an internal process where if you want a SoftLayer account, you're going to get one that has some usage limits on it to start with, like a certain number of VMs and a certain amount of bandwidth. And then if you go over that, we'll have to go through an approval process to get a bigger account. Also, we just have people request buckets of money every month, how much they think they're going to need. So at least to put some wrapper around that. So now we're ready to do some hybrid cloud stuff ourselves. So we've had hybrid cloud support in our product for a couple of years, but we didn't really use it a lot on our development team until just the last couple of months. So this is the public cloud gateway. So it's OpenStack based, and what it is it it lets you deploy virtual machines to a variety of different cloud providers. So basically, you set up OpenStack region servers for your private clouds, and then you set up the public cloud gateway for the public clouds, and in the end, you have an abstraction where cloud groups represent data centers or clusters of hypervisors, such as a vCenter or a KVM cluster. And then hypervisors in here represent public cloud data centers or hypervisors at the individual compute node level or ESX server. And then once you have them modeled in the system, you can then create virtual system patterns around it, which are kind of like heap templates. I showed you the one with Chef earlier, where you can drag and drop your machines in and then have them start up and talk to each other. You can run business processes against them, and probably most importantly, you can see everything from one place, so you don't lose your infrastructure. And it gives you a consistent interface across different cloud providers. So, yay, Hooray Cloud. Now we got hybrid, but more problems, right? So the first one is a visibility problem. Where is my infrastructure? We find that a lot of people, when they start using hybrid cloud, they just can't keep track of where things are. They have spreadsheets everywhere, and it's bad. So something like Public Cloud Gateway that I just showed you is extremely helpful for that. The next one is networking, and this is maybe the biggest pain for us. So every cloud provider does networking differently, and we end up with like a proliferation of VLANs and subnets and firewalls and VPN tunnels all over the place. One thing that we're working on, motivated by this, is re-architecting our applications. So wherever possible, they just have one-way communications from our private data center out, because when you have the two-way communications, that's when it gets more difficult with VPN tunnels. And another thing is that you can let Chef manage this wherever possible, right? So you can let Chef manage your firewall configuration, your static routes, VPN tunnels, load balancing configuration, and managing the differences you have between different environments and nodes. Next problem with hybrid. So bursting is great, but can your application scale down? It's harder than it sounds. So it's really easy to scale up, but scaling down means removing a server from your infrastructure. And so Chef really helps with this as well. It can gracefully reconfigure your load balancer, take things out of your pools, shut down your services for you before you delete the virtual machines. Another thing that's great is a tool like Chaos Monkey that will just randomly kill servers, because then you get practice at making a truly reliable system. And if you can kill a server at any time, it's really easy to take one out of your pool. Mostly, this is a matter of practice and testing. That's why I came up wrong. But speaking of testing, hybrid cloud will expose many new bugs, and the good thing is that Chef can help find and fix those bugs. So when you have your infrastructure as code and everything is in source control, you're keeping your environmental differences under control and sort of quantified. Also, if you have the recipes that get all of your images to basically the same starting point, that helps with testing and debugging. And finally, enabling continuous testing pipelines, like I showed you earlier, is great for this. So, how am I doing on time, by the way?
You have 15 minutes left.
Okay, good. All right, so this is the next thing that we have now. So this is private hosted cloud, probably something people are not that familiar with, but basically we can stand up a private cloud for you in SoftLayer, which is a public cloud, because SoftLayer can do hardware as well. So we can order some hardware in SoftLayer, stand up a private cloud, and give you the keys to it. And so this is nice because if you were to have us come on site to do this for you, it might take a week or something for a person to do it. By doing this out in SoftLayer, we can use automation, and there's like lag time when things are running, but it takes about 2 days. And it's not, you're not charged for 2 days of person's time. It's only a few minutes of a person's time while things are running. So we automate this as much as possible, and it uses the same chef recipes. So we found that other than the networking, really nothing had to change here. So that was great. All right. Now, I had a promise in my talk that I was going to show you some ridiculously simple software bootstrapping, how to get Chef installed on software systems using Dropbox. So I have a video for that. Let me grab it. Get my mouse here. And is it running? Okay. So first what I'm showing here is I'm getting the curl URL for Chef, which is the same for most Linux distributions. I'm pasting it into a test Dropbox shell script, and that basically echoes hello world to a file and then installs Chef Workstation. And that's Unix, because Windows. Then I put it in Dropbox, and you could put this on a server, a web server that has HTTPS, but I said ridiculously simple, so Dropbox is what I used here. And then Dropbox will give you an HTTPS URL for any file, and so that's what I did there. I copied and pasted that. Now I'm going to go to software and order a server. So I'll just show you what that process looks like. So I select my data center. And then I'm going to take most of the defaults here. Change the operating system a little bit. Blah, blah. Features I don't need for this. And then continue the order. And so the magic is on the second screen here. There's an order summary, and then it's going to ask for the host name and so on that I want. And there is a provision script URL. So I'm going to take the URL from Dropbox and paste it into there. I mean, this is a dead simple script. You can imagine how once you have this, you can just expand on it. And we actually do use this. We have some pretty fun scripts now. So great, I pasted it. I give it a host name. Is it okay? Yeah, you didn't need to see my billing information, so. So, okay, it places the order. Great, here's the receipt. Now I'm going to go over here and wait for the machine to be available. And this works for bare metal as well as virtual machines. Same mechanism. And at first it says it's not available. Now it says it's running. I have a host, an IP address, an ID, and password out there. So I'll just log in. And there you go, root password. And first I'll just cat the test file that I wrote. You can see it there, helloworld.txt. And then show that Chef is up and running, -v. So ridiculously simple. Yay, success. So that's my demo. You can do it too. Now let me just show you one more thing. All right, so one thing that I hope will make you guys happy is that I am in the middle of open sourcing a few of our bootstrap scripts. So we have one to bootstrap DevStack onto a bare metal server. We have one to bootstrap KVM, and we have that little test script that I just showed you. So hopefully that'll come in handy for some people. Oh, and we have one to bootstrap Chef and write a node file with recipe in it so that it runs recipe. So hopefully those will be available in a couple weeks. It takes a little while to jump through the legal hurdles, but when they are there, I think that they will be at that GitHub address. So github.com/anfred/softlayer bootstrap. And yeah, I also have office hours coming up at 3:55 in the Marina room, or I'm on Twitter if you need me, or I'll be at the IBM booth during breaks. So are there any questions?
Where does SoftLayer fit into Bluemix? How are those two related?
I'll have to get back to you on that. I'm not an expert on Bluemix, so I will check. How does SoftLayer fit into Bluemix? Do you know?
Well, SoftLayer is
Yeah, is Bluemix hosted on SoftLayer now? I think so too, but we'll check. Yeah. So yeah, Bluemix is a platform as a service that lets developers build composable applications so they don't have to start from scratch. And there's a lot of services out there that you can take advantage of, like we have DevOps development pipelines, monitoring that you can get. You can import services like mobile and social feeds and things like that. Yeah. Any other questions? Great. Well, I'll give you a few minutes back. Thank you so much.